So I think Daniel, you did a great job of setting up what we're here and what I'm going to talk about. It really is focusing on setting policies that are setting policies for cloud infrastructure using a combination of Crossplane and OPA. And I always like to start out these talks with a couple of very simple statements to just get the ball rolling. And so the first of those is that, as we all know on this call, Kubernetes is responsible primarily for running applications, right? That's why we use it. That's why it's so valuable. But at the same time, we also know, second simple statement, is that developers are the ones who are responsible for telling Kubernetes what to run, which applications, how are they configured, and so on. And what's pretty exciting to me is that what I love about Crossplane is that it allows developers to also tell Kubernetes what infrastructure to use to run their applications. And so from a single API, from a single user experience, you can control both the applications and the infrastructure it runs on, which is pretty powerful and important. The observation, and really the starting point for the rest of this talk, is this observation that developers can make mistakes. When developers tell Kubernetes to go ahead and run a pod or a deployment or any sort of compute instance, they could accidentally tell it to use images that have vulnerabilities that didn't come from a trusted registry. Or maybe they accidentally configure the network policy to allow arbitrary egress or arbitrary ingress traffic. Or maybe they try to launch a new ingress on top of Kubernetes that uses the same host name or DNS as another existing ingress. Or maybe they try to launch a database that's just out of bounds in terms of it being too large and requiring too much memory and disk for the organization. And so all those kinds of mistakes are just things that people make. And so there are a couple of options that we have in terms of avoiding those mistakes. One of which is to train developers. So this is often what we do, and we do this actually all the time, regardless of what else we do. But we always try to train our developers. We send them emails. We post these policies, these rules, these regulations, these guidelines to wikis. We put them in PDFs or Word documents, right? We communicate the rules and regulations, the pitfalls that the mistakes that they might make in an effort to help them avoid making them. But at the end of the day, this option effectively relies on people, and people make mistakes, and that's certainly something that we see happen all the time. A variant of this is where we not only train the individual developers who are launching applications and configuring applications in the infrastructure through Kubernetes, is to embrace a GetOps style of rollout and ensure that all of those resources, all that configuration that developers choose goes through peer review. And that only once someone else has actually verified that the resources are safe, do those resources get placed onto the Kubernetes cluster. This is important. We love this. And again, this is something we see people do all the time. But what I'm going to really focus on today is option 3, which is to embrace automation, which is to take those PDFs, those Word documents, those emails, those wikis, take the rules and regulations out of all of them and codify them in software. Create policy as code, just like we create infrastructure as code. Take those rules and regulations, put them into software so that now software can enforce those rules. So that, if we've been on call for 24 hours trying to deal with an outage and we fat finger a configuration, that, we've got a piece of software that is now responsible and able to help us avoid those mistakes that could cause outages or security vulnerabilities or compliance missteps. So that's kind of the idea here. Policy as code, that's what we're going to be talking about today. And so this is where the Open Policy Agent comes into the picture. The Open Policy Agent is effectively, for those who haven't used it, an incarnation of policy as code. It's totally open source. It is owned by the CNCF. We started it here at Styra a few years ago, donated it as a sandbox a contribution to CNCF. A couple of years later, it's now at the incubation status. It's got lots of folks who are using it. Certainly, I'll call out. I think I do that in the next slide. So I think that the goal of OPA really is to provide this system that allows people to codify real-world rules and regulations, put them into software, and then enforce those rules and regulations, regardless what those rules and regulations apply to. So the way that OPA works is that, and this is the same picture that I would draw for really any kind of integration between OPA and some other software system. Here we're talking about Kubernetes with Crossplane. The way that OPA works is that it embodies this general purpose policy engine idea, and so when Kubernetes receives a request from an end user to spin up a new database through Crossplane or through to create a new ingress or deploy a new application, that Kubernetes is configured to go ahead and ask OPA, hey, is this new resource, is it safe to deploy on the cluster or is it not? OPA makes a decision and then returns that decision back to Kubernetes. It's Kubernetes, the API server specifically, that's responsible for enforcing all of these policy and authorization decisions. It's OPA's responsibility to make the decision. And so often I'll go through a much longer introduction here around, the fact that OPA's queries, the queries that you send to OPA, the requests that you make of OPA can really be any arbitrary JSON. In Kubernetes case, what that would amount to is the entire content of that YAML file that developers are using to actually configure their applications and infrastructure. And so that entire 200 or 500 lines of YAML is what's sent across to OPA to make a decision. And then OPA's response is also arbitrary JSON. And as you'll see in a moment, typically what we see in terms of people writing policy is that the decisions that people make for Kubernetes amount to a list of error messages, a list of problems that this new configuration, this new resource, this new YAML file has, and so therefore should not be deployed to production. The one thing I'll mention here is that OPA is the general purpose policy engine. So here we sort of talked about this in the context of Kubernetes and motivated it that way. But what we also know is that OPA can and is used heavily through many different use cases throughout the cloud native ecosystem. OPA Gatekeeper is a project that aims to provide a native Kubernetes interface between OPA and Kubernetes. So it's definitely check that out if you've got this Kubernetes use case in mind. Okay, so let's look at a quick example of how this would work. Here we're using a Cloud SQL instance from Crossplane. The idea is that imagine I'm a developer, I'm trying to create this Cloud SQL instance. And so I start out with, here's the YAML for this Cloud SQL instance. And what I've highlighted there in that blue circle is the size of the database. So here the size of the database is 300 gigabytes. And let's say that in our PDF and our wiki, the real policy that we have is that all Cloud SQL instances must not be larger than 200 gigabytes or some other smaller number. And so now the question becomes, well, how do you use OPA and policies code to go ahead and enforce this policy and make sure that the developer doesn't deploy a database that's too large? So the way this works is that I, as a developer, run kubectl or maybe through GetOps, it doesn't really matter. This YAML file gets sent through the Kubernetes API server. It goes through at least three stages you see here. Authentication, which is, am I as a user even allowed to talk to this Kubernetes cluster? Authorization, this would be where RBOC comes into play. This would be checking that, let's say it's me, Tim, making sure that Tim has the ability to create a Cloud SQL instance at all, right? That's sort of what authorization or RBOC give you. Admission is the third stage, and that's where this entire chunk of YAML gets handed over to, in this case, OPA. And then a decision is made whether this particular configuration of this Cloud SQL instance is authorized, is safe to deploy, or is it not? And so that's where OPA comes into play. So imagine now that OPA has been given some YAML that you see there on the left-hand side by the Kubernetes API server. And now OPA needs to decide whether or not this particular resource is safe to deploy or not. So here I'll quickly walk through how you would write this policy in OPA's policy language. As I mentioned a little bit ago, the kind of policy decision that typically we see people write for this Kubernetes use case is to return a list of error messages that indicate exactly why this new YAML file is not safe to deploy to the cluster. If that list of error messages is empty, well, then it's allowed. And so the first thing that we're doing here is we're going to construct an error message called MSG, and we're going to be assigning it to the deny set. And so the syntax is a little bit wonky here. The rest of the syntax, I think, will be easier to follow. So now inside of this deny is just going to be an if-then statement. It's going to be if a bunch of conditions are true, then we're going to include this message in the list of deny responses that we send to the user. And so the first condition in that list is just checking that, in fact, the request we've been sent is actually a Cloud SQL instance. Then we're going to check that the operation is a create. We don't want this to run on updates, for example. We could and maybe should on updates, but we definitely don't want this to run on deletes. And then we're going to go ahead and look up the size. So in order to look up the size, we're just going to use the standard dot notation that everyone would, I think, expect in this, and to dig down through input.request.object.forProvider.settings.data disk size gigabytes. And we're going to assign that to the size variable, and then we're going to check if the size is greater than, oh, this should be 200 here. And so now finally, we're just going to construct the error message that gets returned to the user, which is just to say that the database size in gigabytes is larger than the limit of 20. Okay, so that's the policy that you would inject into OPA, and there are a couple of different ways to do that. I'll kind of show you one, but once OPA has this policy, it goes ahead and evaluates that policy over this YAML file that you see on the left, and then if it returns any error messages, then OPA will return that list of error messages to the Kubernetes API server, and the API server returns that error message to the end user and rejects that new YAML file. If the error messages are empty, then the Kubernetes API server will go ahead and accept the new resource and pass it along to the cluster. All right, I'll do a quick demo here. All right, so what I'm going to show quickly is first we will start out, and I'll just walk through exactly this thing that we did in the slides a moment ago. So here's our Cloud SQL instance. Note that here, well, we've got 30, so the policy is going to be 20. So the policy is going to say you can't deploy databases that are bigger than 20. This one's going to be invalid because it is of size 30. And so we'll just go ahead and so the first thing we'll do is just demonstrate that, in fact, there are no policies in place, and so this gets created just like we'd expect. So let's go ahead and get rid of that. Okay, so now it's deleted. And now, in order to write policy and put it in place, I'm going to go ahead and demo Styra's commercial product that, while OPA and Kubernetes work really well together, especially with Gatekeeper in the mix, Styra's product just makes them work even better together. And it's just an easy way to go ahead and show you how to put policies in place very quickly. So here we'll go ahead and open up the policy that is for validation. These validating policies, if you know Kubernetes, what you know is that you have a couple of choices with Kubernetes in terms of admission control. You want to put validating policies in place, meaning you either accept or reject, or do you want to put a mutating policy in place, which allows you to actually change the resource as it before it's accepted onto the cluster. So here I'll just this is basically just the exact same policy I showed you a bit ago. There are just a couple of tweaks, but otherwise it should be working. Now what's happening under the hood here is that OPA is periodically phoning home and downloading those bundles, and so now hopefully it has done it, so that yes, in fact, now if I try to reapply that same Cloud SQL YAML file, we now get this error, and this is just obviously from Kubernetes that the database size of 30 gigabytes is larger than the limit of 20. And so here's the exact error message that we constructed in that policy, and you see it being returned directly to the user. The last thing I'll show you super quickly is that you can, in fact, also, remember, OPA is a general purpose policy engine. So what you can also do is, as I alluded to, put policies in place that enforce and then actually mutate that resource. And so that's what we're doing here. So this policy just says, well, look, if the size of the database is too large, then go ahead and change the database to be the maximum allowed size. You always want to do that, maybe not, but certainly this illustrates the functionality. And so again, okay, and the other thing to keep in mind is that mutation runs before validation. So at this point, I've got both mutation and validation policies in place. And so if I flip back to here, and I go ahead and try to apply the same one, what you see is that, in fact, that resource was now created, but it was created, and if we actually go look up the size, what you see is that it was created, and in fact, the data disk size in gigabytes was changed to 20. All right, so hopefully that gives you a quick overview of what can be done with putting policies in place to go ahead and put some safeguards around your Kubernetes cluster. You can do both validating as well as mutating policies to make sure that whatever guardrails you need are actually in place. Last thought here, two last thoughts here, one of which is I mentioned that OPA is a general purpose policy engine. We illustrated it mainly for Kubernetes for looking at application configuration as well as with Crossplane infrastructure configuration in the Kubernetes space. But this is the usual slide that we show of all the different use cases that people have rolled out into production for OPA. So microservice authorization is another one. Database authorization, especially Kafka, has been popular of late. People use it for Terraform as well, Linux Docker and CI/CD pipeline as well. So there's the overall goal of OPA is to provide a unified policy framework for all of cloud native. And so I think what I see is that OPA and Crossplane are really cousins here in the sense that OPA. The goal is to provide unified policy across the cloud native landscape. And obviously, Crossplane is providing unified infrastructure across clouds. And so these are definitely better together. Unified policy across unified cloud infrastructure. What more could you ask for? Anyway. All right. Well, thank you all for giving me your time today.